And I'm a member of the Electric Truck Project, mentored by Ron Grosinger. For some of you may not know, but this project actually has been going on for 2 years now, and quite a lot of team members have joined and left. So far, they've assembled all the electrical components and laid them out in a plywood board, and this will later then be put into place in the truck itself. They also pulled out the old combustion engine, and it's just sitting out in storage. They also made a metal support. This is for the electric motor, so it'll actually hold everything in place. As well as earlier this year, we moved the truck to SA-119, where it's currently being held at. During summer one, the current team continued to develop their skills and knowledge in order to work on the truck much better. This included basic machining, welding, learning design, and understanding how to use the multimeter as well as reading wire diagrams. But we also worked on the coupler, and so what the coupler essentially does is it connects to the transmission and the engine as well. So here you can see the old coupler over there. This slides into your engine through the motor shaft, and once that's connected, this part here, the bolt cabinet, can be connected to the transmission. Without this piece, or if this piece is broken, that means that we can't transfer power to the wheels. So this piece actually has to be really, really strong and really, really robust. However, our current design isn't that well. When we tested it, we found a stress riser here, which essentially concentrated all the force into it, leading it to break. Of course, we also used a 3D printed part, so that could also be to blame. But when we did a force analysis on it, it's still evident that there was quite a lot of stress located in that stress riser, in that 90-degree angle. This is just a basic force analysis on Fusion 360. However, it's not that accurate because it's not a real torsional analysis. It's just I put a load here, and it would push all the force to the left. That's why it's mostly concentrated at the upper left corner. In a real force diagram, torsional force diagram, most of the forces will actually be spread more evenly. It would still show this riser right here. And so we tested our first design. We wanted to reinforce that connection piece, so we added gussets to it, and gussets pretty much bulk up the entire coupler. And we found that this does relatively well, but not well enough to handle what forces that we need it to handle. And so we moved on to the second design, which is just a bigger, more robust gusset design. I guess this one did exceedingly well compared to the first. However, we still wanted to test a couple more designs. So we ended up with probably the most basic and probably the strongest one, which is just a solid piece with a tapered end, as you can kind of see. This one did extremely well, and it distributed much more of the stress around. But like I said, these force analyses aren't really that accurate, so we opted to test this with a 3D printed version. It's around. And so these 3D printed versions were applied with a torque, and we increased by 10 foot-pounds per crank. And what we found was our original coupler was held up to 40 foot-pounds of torque before snapping. The first design to the left of it handled at 60 foot-pounds, which is pretty good. To the bottom of that is our second gusseted version, which handled 50 foot-pounds of torque, but it didn't break. It actually just moved the material around, and this was actually expected because the gussets kind of warp when they're applied load. Finally, we tested just a solid piece. This one held up to 80 foot-pounds of torque. To put that into perspective, your typical wheel lug nuts would require like around 80 to 90 foot-pounds of torque. So this could probably hold up a wheel. What we want to do next is to create steel versions of this, just scaled miniature versions, but it'll give us a more accurate representation of what forces these can handle and what the characteristics are. Because the 3D printed version is plastic, and plastic has some different characteristics than steel or aluminum. So we'll hopefully get that tested by this summer too. And we want to finalize the coupler design and make it by fall, hopefully. Once that's done, then we could just move on to the motor and transmission mounts, which essentially hold up the entire piece and bolts onto the truck. Once that's done, we need to create a removable battery container. If anyone has any ideas on how to do it, I'd be more than happy to hear. You can send ideas, questions, or concerns to our blog our email at theelectrictruckproject@gmail.com. Or if you're interested or like curious to see what's up, you can follow us at ttppcc.blogspot.com. Thank you.